Hi, welcome to MTH129 Discrete Maths. Now, mathematical things can be sort of split up into two sorts of categories. One category is continuous, and that is where numbers just keep coming. It's lots of decimals, and you do subjects like calculus based on that. So it's more like the flowing tap. What we want to focus on in this subject is the other sort, which is called discrete numbers. So discrete numbers are ones which have gaps in them. So a bit like not a flowing tap, but a bit more like the dripping tap. So ones that there's a gap between every single number. So integers are the common idea, but you see it in all sorts of things. So when there's ever gaps between them, so you see them in graphs, and we see lots of these sort of things in computers in particular. And so discrete maths ends up being a really useful tool to understand lots of stuff with your computers. And that's sort of what we're going to focus on in this subject in particular. We're going to look at all sorts of things in this subject. One of the first things we look at is the idea of logic. And this is the idea of looking at true things that are true or false and how to combine them. So things like and ors, which you see very commonly in computer code. But they are also the fundamental basis of proofs, which is really key to mathematics. So we'll see lots of things in this area. Another thing we'll look in this subject is how to represent integer numbers in different sorts of ways. There was a book, radio play and movie all in one, called Hitchhiker's Guide to the Galaxy, and there was a computer that was tasked with working out the answer to the life, the universe and everything. And after a long time, so millions of years, it finally arrived at the answer of 42, which is a good joke in the book. And so the question is, why 42? Well, one thing we're going to look in this subject is how to represent numbers in different ways. So computers thinks in terms of binary, and we often try to represent in terms of hexadecimal. So you can think of it in different ways. And what I like at 42 is, if you look at the binary representation, it's yes, no, yes, no, yes, no, or 10, 10, 10. But we'll look at lots more of these sort of things, and this idea of understanding decimals, or hexadecimals for short, is really integral to understand lots of things in computers like the new internet protocol, etc. Another really useful thing with discrete maths is looking at discrete probabilities. They're useful for many things. An example that you could use them in business, something else you might consider is game. So in a computer game, you'd set the probabilities of a certain artificial intelligence staying or moving left to right, and with probabilities you can make it less predictable what the character is going to do, and therefore increase more challenge to the game. And so understanding how to calculate and deal with these is really integral to lots of things you might want to do. Discrete maths is not just numbers though, and so a really big part we're going to look at is look at the idea of graphs, and a special types of graphs called trees. And these are really key things for data structures in computer science. So looking at, say, social networks, or using them to do a spell checker. So this tree on the right hand side, you can see in the picture here, is called a prefix tree. If you look at it carefully, it stores the words card and cart and carry, celery, cat, etc. And this is a good way of doing spell checkers or automatic completions. And so these sort of discrete things, or discrete data structures, are really useful in computer science, and we'll look at them later in the subject. Now, a really fundamental thing with computer science in particular is looking at the idea of algorithms. And they are pretty much the functions that you would use to do things. Now, we have algorithms in mathematics as well, just pure mathematics of just how to solve a certain problem, but it very much fits in the world of computer science. So we're going to look at different algorithms later on. In particular, we want to work out, how do you compare to different algorithms. So on the screen here, we can see a merge sort and a bubble sort, two different ways of sorting data. How do you know which one is the best one to do? Which is the most efficient? How long does each one take? How much space it takes? And we're going to start looking at ways of trying to measure those things in a way that we can compare, called big O notation. So we'll do that much later in the subject, and in doing so we'll look at the idea of recurrence relationships and recursion that goes with it, and the idea of recurrence relationships are very powerful mathematical techniques that are useful much more outside computer science, but certainly we'll find them useful for the things we want to consider in the subject. We will finish our subject in discrete maths looking at what's called Boolean algebra. Boolean algebra is a way of looking at truth tables and sets and many other things all in one go. And one thing that's really useful for is looking at logic circuits. One application that we'll certainly find really helpful is, given any logic expression, potentially it's quite complicated, looking at how to bring it simplified and to therefore be able to create say a digital device or a simplified expression in order to evaluate. And looking at those sort of things. So I really hope you're looking forward to the subjects. I certainly looking forward to it, and to find out lots of things that can really equip you for your later studies in computer science or mathematics.